Today's topic is match register, that is timer 0 match register 0. So before this, we should know something about this prescaler peripheral clock. This peripheral clock. So what is this peripheral clock? It's the signal which drives all the peripheral models inside the microcontroller, like timers, UARTs, I2Cs. Okay, this is called peripheral clock, and I've taken 12 megahertz. So this is about peripheral clock. And now, what is prescaler register? How many peripheral clocks are needed to make one timer tick? This is taken care by this prescaler register. Okay, so here I've taken this prescaler register 12,000 clocks. How I'm getting this 12,000? See, in 1 millisecond, I want to increment this timer counter by 1. In 1 millisecond, I want to increment this timer counter by 1 count. So in 1 millisecond, I'm getting 12,000 clock cycles. Okay, so I've set prescaler register is 12,000. Why I've taken 11,999? Because counter starts from 0 to 11,999. Okay, now what is this prescaler counter? See, on every peripheral clock rising edge, this prescaler counter is incremented by 1. Now, if this prescaler counter is equals to, when it reaches this value, what happens? When this prescaler counter reaches this value, what happens? This prescaler counter resets, rollovers, and now this timer counter is incremented by 1. This is how the timer counter is incremented in 1 millisecond. Now, what happens when timer counter matches timer or register value? Okay, in my code, I've considered this timer 0 match register 0 500 value. So, and I've set this timer 0 match control register, this one 0 cross 03, that is 1 1 interrupt and reset. What happens? See, when timer starts counting, like as we know, it starts from 0. So when it starts counting from 0, when it reaches to match register value this much, when it reaches to this value, what happens? Match occurs now. When timer counter reaches 500, this value, match occurs. So then two actions happens because of match control register. These two actions, interrupt and reset. Okay, timer counter resets and ISR is generated. I mean to say, this interrupt is generated. And again, what happens? This timer, as I said, timer counter is resets to 0, and again it starts counting again. I mean to say, this cycle repeats. That's it. Let's consider this timer counter as a stopwatch and match register as alarm time. Okay, and when match occurs, alarm rings. Okay, see what happens. Just according to the theory, means when a timer counter starts counting from 0 to 1, 2, 3, when it reaches this value, 500 value, what happens? A match occurs. When match occurs, what happens? Two conditions will take place. First one is ISR is generated, And again this timer counter is resets to 0. Again the same again this cycle repeats. Again this timer counter starts counting from 000, and again when it reaches to this 500, match occurs, again generates, again it will reset. This is the process of this timer counter. If we consider this real-time example, let's consider this timer counter as a stopwatch. This one as a stopwatch, and this one as a alarm time. Okay, when timer when this stopwatch, I'm considering this one as a stopwatch. When stopwatch starts counting 0, 1, 2, 3, when it reaches to this value, that is alarm time value, what happens? A match occurs. Match occurs. What happens after that? Alarm rings. When stopwatch start counting from 0, 0, 0, 1, 2, 3, when alarm time occurs, that is this value, a match occurs. At that time, what happens? Alarm rings. Again what happens? Again this stop watch resets to 0. Again starts counting. This is the procedure.